Okay, next up, this is going to be awesome. We have Emmanuel from Anthropic with a very spicy title for his talk. It is Everything We've Been Taught About ML is Wrong. So let's see what he has to teach us about what's new in the world of ML. Hey, Emmanuel.
Hello. Thanks for the intro.
Yeah,
I think everybody can see my slides, so I think I'll just get started.
they look good. Take it away.
Perfect. Thank you. So spicy title, just as clickbait. The takes are much more nuanced, but I think there's a lot of truth to this. And so, basically, the inspiration for this talk is that I've been working in ML for almost 10 years now, and I found that like a lot of my fundamental intuitions, now that we've moved in the world of LLMs, are wrong. And so I'll tell you a bit about why I think that's the case. So, who am I? Why should you maybe listen to me? I'm Emmanuel. I work currently at Anthropic, although I just started very recently. And I work as a research engineer to like improve the LLMs here. Before that, I was at Stripe for a long time, where I worked on like building models, improving models, and a lot of ML opsy things, like automatically evaluating and deploying models and that sort of stuff. And then before that, actually, I worked in ML education, where I developed a lot of these kind of like teachings about ML that I would teach to people transitioning into the field. I mentored over 100 data scientists that would like transition and become data scientists in industry. And so I had a lot of strong opinions about what are good and bad ideas when you're doing an ML project. And over the last couple of years, I found that all of these strong opinions are outdated. So what are we going to talk about? So here's some of the ML fundamentals that I used to teach. The first thing is like start with a simple model. This is, again, something that kind of like makes sense. It's like if you are going to do any ML task, you should probably take the simplest possible approach and try that. And if that works, good, move on. If it doesn't, maybe it's a very hard task, but you should definitely not start with like a super complicated model. So that might be like logistic regression if you're doing kind of like tabular classification, kind of like fraud prediction, like what we did at Stripe. That's a great baseline. Bag of words if you're doing NLP, or maybe transfer learning or ResNet if you're doing anything in computer vision. What else should you do? You should probably use relevant training data. That seems like a truism, but it's like if you want to take again the Stripe example, like predict fraud, well, you should take a data set of like credit card transactions, good and bad, and then train on that. If you instead took a data set of like, I don't know, like patient care information from a hospital, you wouldn't expect to have a good fraud classifier. Spam classifiers can't be trained on kind of like a review data set. Don't use synthetic data. This is maybe like a more spicy take I had, but I found that in practice, it was very hard to get synthetic data working. So like specifically model-generated data, I feel like in the recent history of ML has not often done well. So like people have often proposed like using GANs to like make your ML models better. But in practice, that seems to always be hard and finicky, and your model is very good at like usually detecting that, this is kind of like fake data, you're passing it and overfitting onto some like synthetic feature. And finally, like I guess like beware of automated metrics. It's easy to fool yourself into thinking you have a great model without looking at the data yourself. The most naive example of this is like people reporting 99% accuracy when they're working on a problem where there's 0.1% of positives and the rest of negatives. You would get 99.9% accuracy by just always saying no. And so looking at the data is always useful. And finally, this is kind of like the converse of use relevant training data. It's use a model only on the task it was trained on. That kind of makes sense. You're training like a fraud classifier. Again, you're not going to use it to like predict, if a review is positive or not. Cool. So I'm going to go through each of those and explain to you why I think they're categorically wrong now. So start with a simple model. I was so convinced by this that I like wrote a blog post about it. And my recommendation was always like, yeah, just try like the simplest, stupidest thing you can think of. Logistic regression usually is great for anything that's not NLP of computer vision. And that's just because it's the fastest way to kind of like get an initial result and the fastest way to decide whether it's worth investing more time and what it's worth investing in. But now, if I want to write a regular expression, I don't. I just use like an LLM instead. If I want to like do something as simple as wrapping every element of a list in parentheses, I use an LLM. If I want to like reformat something, I use an LLM. And so we've gone from like use a simple model to do a complex task to like use an incredibly complex model to do a simple task. And so, why has that happened? Well, I think the meaning of simplicity in the context of this expression has changed. Simplicity used to mean like, a simple model in terms of like how hard it is to build, but really the goal is to increase iteration speed. And so you should just take the shortest path to results. And that used to be correlated with taking the simplest model, but it's not anymore. And why is that? Well, let's take an example. So like, what's the best way to estimate whether you can like classify some text, which was something we would like commonly do at Insight at my education job? Well, in 2015, you do like logistic regression and bag of words. It takes you half a day, and you have a pretty good baseline, and you can tell, whether it's possible or not, whether the data is good or not, etc. In 2019, kind of large-ish models were starting to be released, and so you just like fine-tune BERT. That would take you a couple hours, and again, would give you like a really good baseline, faster than logistic regression, slightly more complex model. Today, just use an LLM, just like ask it to do the thing, see if it does the thing, and then like you're much better off, and that takes you 2 minutes. And as astute observers will note, these models are getting increasingly more complex, right? Like a logistic regression might have 1,000 parameters depending on the dimension of your word-to-vec embeddings. BERT has about 110 million. LLMs commonly have over 100 billion, although of course that depends. So start with a simple model? No, start with a competent model, I think, is really the new version of this. And as with all these hot takes, there's going to be a bunch of exceptions. Like if you're doing something that's not NLP related, maybe that doesn't apply, or something that you cannot easily ask an LLM to do. Of course, you might still want to start with kind of a simple baseline. Cool. So use relevant data. If this was live, I would do a poll, like a kind of show of hands. But if I asked you which data set should you use if you wanted to, like, for example, generate realistic looking Yelp reviews, and then I should point out that there is a Yelp open data set that has a bunch of Yelp reviews in it. And I should, of course, also point out that this is a trick question. So I'll let you think about it. You can tell me which data set you want to use. You can see if there's like... The answer to this is just use all of the internet, of course. Why would you only use Yelp's data set? If you use the whole internet, you will do much better than if you just train on Yelp's data. Training on Yelp's data only gets you so far. The rest of the internet will give you so many more linguistic abilities and reasoning abilities that you'll be able to just perform much better on that task. And this is a chart from like the original GPT-3 paper, for example, that shows that, kind of like if you take a big model and you prompt it, even zero shot actually, it will do on certain tasks better than a fine-tuned state-of-the-art model. And certainly it's that large model is trained on all the data that like state-of-the-art model was trained on. Probably it's seen it in its training set. And the only difference between them is the model is much larger and has been trained on all the other data. And so now it's not true that you should just train on relevant data. If you have a model that's large enough, you should just train on all the data because it'll make you better at all the things, which is also like a ridiculous proposition, I would think. Like would be a ridiculous proposition like 5 years ago. Again, if you were training like some spam classifier and you told me like, well, I'm also going to train, on sentiment analysis, I would tell you that that's a terrible idea and that, you probably aren't fit for machine learning. But is this surprising? Well, if you think about it, this is kind of like an extension of transfer learning. If you've been doing machine learning for a while, kind of transfer learning on ImageNet was the first similar example where you could train, a computer vision model on your own data, or you could train one that was trained on a massive data set, ImageNet, and then fine tune it a little bit on your data, and you'd get much better results. If you think about it, the kind of like LLM 0 or 1 shot in context learning is just an extension of that, where, in 2015, you would like train on your tasks data. In 2019, you would like train on a huge data set and then fine tune on your data. And then now, we can just train on an absolutely staggeringly large data set, and maybe we don't need to fine tune. I put a little asterisk here because I think, fine tuning LLMs still actually provides benefits, but certainly they give you much, much better performance than any model before without any fine tuning. So use relevant data? No, just use all the data, siphon it all. Again, caveats, you want to use all the good data, not use bad data, and only use data that you have actually like the ability to use. Cool. So the next one is, I think, like use human-made training data. By default, this is what you do in every machine learning project. You know, if you're doing, again, like fraud classification, which I was doing recently, you're using like credit card transactions that humans made to like train your model. If you're doing like classifying reviews in terms of like sentiment analysis, you're using real reviews that humans wrote. And model-generated data just has a history of working poorly. GANs to generate fraud data were proposed to me like every couple of years, and to my knowledge, they have never worked on any practical application. SMOTE was a similar technique that's just I found very brittle in practice. Distillation is another approach which works sometimes, but is also challenging to get to work in practice. And so, model-generated data used to be a bad idea if you were on a time crunch, and certainly it could work, but would require a lot of effort to get it to work. And certainly, you would use a different model, not the same model, because having a model generate its own training data would be absurd in the world of ML. You'd be told like, well, there's no additional information that you're entering into the system, and so this is kind of like a snake eating its own tail. If the model you train is generating some data, and then you train the model you trained on the data it generated, then you're just going to mode collapse, and it's not going to be interesting. Or is it? Anthropic, famously released constitutional AI, which is essentially a version of this where, we ask a trained model to read a constitution, and then we ask it to use the constitution to rate whether answers are good or not. And then we train a model based on that. And then we train the original model based on this preference, and the original model is better. And, that whole process is just like train model generates more data, train on that data, and then gets better. Which, I think, again, would have been absolutely wild to think of before, but now it's like a very reasonable thing that gives you a parity level improvement in terms of like how good the model is. So, maybe humans don't need to make training data for long. Maybe we can use model-made training data for a lot of things in the future. Certainly not everything, but the fact that we can use it at all is a huge change. All right. Well, certainly, if we're using models to generate data, we still need to kind of have humans look at the outputs in order to verify that the outputs are actually good. We can't really trust the models to judge themselves. That would also be kind of wild. The thing is, like, evaluating generative outputs is hard. In fact, if you're evaluating like summarization and translation, having a human is kind of like the only thing that we've been able to do for years, because any metrics, like common metrics are called, like rouge and bleu, and there's other ones. They are often very pessimistic because they punish you aggressively for deviating from like whatever label there is. So, if you're translating a sentence from one language to another, you have this kind of like gold translation that your model's trying to match. But if like your model, let's say, like perfectly paraphrases that translation, it'll get like in many of these metrics a score of 0, even though that translation is correct. And so the gold standard is to like ask humans to rate outputs. As I said, having a model rate its own output would be absurd. Like, obviously, it would just like, I assume, like, just say, oh, like, my output is great. I love my output, right? It's been trained to output that output. So according to it, it's the maximum likelihood output it could produce. It turns out somehow that this is not as insane as we thought. This is from the second paper in the sources below, the Machiavelli paper, which talks about kind of like ethical behavior in LLMs and is interesting. But also talks about this fascinating pattern where they have the researchers write a bunch of labels, and then they measure, human crowd workers versus using, in this case, GPT-4, or I think like a little like set of heuristics on top of GPT-4, and they find that GPT-4 is better than the human graders. In fact, it agrees more with their golden ratings than the human raters. So it turns out that if you want to like really evaluate a model thoroughly, you can just use the model. And in some cases, not all, in some cases, it'll do a better job than humans, which I think is also something that would have gotten you like laughed out of any ML 101 course a few years ago. By the way, if you're not convinced by this and you say, well, I'd still like to use human raters, there's another recent paper that estimated that about 33 to 46% of crowd workers, I believe it was on Mechanical Turk, use LLMs when completing a task. And so it might be the case that even when you think you're getting human ratings, you're actually getting LLM ratings, which maybe also explains some of the reason for why the differences between human and LLM raters has been shrinking. Cool. So use humans to judge results? No, just use models to judge results. Use models to train your models, use models to evaluate your models, just models all the way down. Cool. Next one that I think is like also interesting is like in the history of machine learning, you mostly had narrow models, models that are trained for a purpose. You train a fraud classifier to do fraud classification. You train, a spam classifier to classify spam emails, etc. They don't do anything else. To my knowledge, no one at Stripe, ever tried to use our fraud classifiers to write poems. That's just not a thing that these models do. They're not built to do them. They don't even have the capacity to try, right? The architecture doesn't allow for it. And yet people find new use cases for large language models that go beyond token prediction, every day. It seems like, yes, you can use them to like write emails, but you can also use them to like read emails. You can use them to do math. You can use them to write code. You can use them to like simulate code execution. You can use them to help you summarize various documents, et cetera, et cetera. You can use them to generate training data or evaluate model data. It seems like their abilities are just much more general than kind of their intended training objective. And so ML models now have overhangs, which is not a thing they used to have, meaning that they have a set of capabilities that is not necessarily immediately apparent. Those capabilities can be unexpected. There are many surprises. I think in like the abilities of post GPT-3 models that weren't immediately apparent when those models were being trained. It's when they were evaluated by external parties or internal parties that folks found a bunch of interesting emergent abilities. They also have unexplored capabilities. I think this is like slightly different. And so it's like, one, they can do things that you might not expect, but two, even if you spend a while trying to tease out these capabilities, there's no existing at the moment way to like list out all of the capabilities of such a model. And so, once you release it, there will be potentially unexplored capabilities that somebody might discover. Some of that might be great and fun and creative, and some of that, of course, might cause safety risks, the kind of risks that companies like Anthropic are concerned about. And that's, again, not something that you ever had. If you kind of open sourced your, let's take fraud classification, since that's the example I've been using. It's like, yeah, people can use it to classify fraud, but there's no risk that they'll use it to like, try to ask how to make a bomb or something. And so the fact that these models have these overhangs is completely new, and I think a little bit mind-bending as well. So, it used to be that we use a tool only for its purpose, and now we have this general tool, and we can teach it its purpose by prompting. All right, so this is kind of like a whirlwind tour of everything that I think has just changed quite a bit in the last 3 to 4 years. Luckily for us, and for our sanity, some things have remained the same. And I'll end the talk with just a few of those, which is that, it is still the case that the most important thing you can do as somebody that uses machine learning, whether you're building the large language models or using them in your product, is to just, focus on solving a useful problem, not playing with cool tools. I think that's the like number one thing that ML people end up doing that is maybe not the best use of their time, is like trying to build a fancy model to do something or getting excited about new architectures. A lot of the time, spending more time thinking about like how you can solve something is more useful. And I think that's even more true in kind of like LLM worlds where, you might get a lot more value from cleaning up the data, as has always been the case, that you pass into your prompt as zero-shot examples, right? Like better data here has huge effects, or you might get better value from like prompting better, as opposed to trying something much more complex. Models aren't magic yet, and I say yet in a cheeky manner. I don't think they actually ever will be, but some of their behavior can feel magic to us, but they still hallucinate, as the panelists were just talking about. They still make mistakes. They still have biases, and so kind of like I think any good and responsible ML practitioner, builds around that and kind of like almost treats the model adversarially in some cases, where it's like, okay, well, I know that sometimes this model will be wrong, so I need to build my product around that assumption. If you're doing anything that has to do, for example, with like providing advice to a user, you might want to like verify that your model actually is outputting something that's true before returning the response, and that's just as true now as it was true before. Engineering skills are always key. Certainly, they're key if you're building these models. These models are kind of like just basically using supercomputers at this point, and so like that's just a very hard engineering problem. But also, in kind of like deploying these models. You know, it used to be that, yeah, you were deploying the like model itself, and now maybe you're deploying like your prompting server. But we, again, in the panel, we're just hearing about how much work goes into like, you know, carefully like crafting prompts and getting results and like post-processing them and detecting latency spikes and kind of addressing them in various ways. And so engineering skills, I feel like in my ML career, have become more and more important every year. And I think that that remains true. MLOps, you know, still as big of a thing as it used to be. People have tried to call it LLM ops now. I think we can just stay with the MLOps name, not to revive the flame war. But, you know, I mean, that's a lot of the challenge of deploying these models, and that certainly hasn't changed with LLMs. If anything, like handling breaking version changes in LLMs is, I think, something that's going to be thought about quite a bit, and is a new MLOps challenge. Monitoring, you always need to do it. Many ML projects have failed silently, and then, you know, 3 to 6 months later, somebody realizes that the model was doing something completely wrong. This is also true with LLMs, and so it's also useful. Cool. That's about it. Whirlwind tour. I'm glad we got to cover it all in just a little over the allotted 20 minutes. Yeah, thanks for listening. You can reach out to me, you know, at MLPowered on Twitter. You can reach out to me on LinkedIn as well. If you have questions, I'm also at Emmanuel at anthropic.com, so you can email me there. But yeah, that's most of it.
Awesome. That was so amazing, Emmanuel. I thought that was like really insightful. And yeah, just like so many things blew my mind in terms of like how we thought about things in the past and how to think about things differently, especially like the one about models, judging models. I think that sort of blew my mind a little bit, not what I expected.
Yeah, it's crazy.
So, well, there's a little bit of a delay, so I want to give people an opportunity to ask questions if they have them. A couple that I'm already seeing in the chat. One from Marwa. She asked, how would you take a generalized model and let it evaluate itself on a specialized task? Not sure if you want to tackle that.
Yeah, I think that's a good question. So, I mean, for what it's worth, we can maybe, I can actually go back to that slide, because that's essentially what they do. So in this slide, they take a pretty general model, GPT-4, kind of like definition of a general model, in my opinion, and the task they're actually running in this is they are asking various models to, like, if I remember well, to be deceptive in various ways, or harmful in various ways. And then they're asking crowd workers and this model labeler, like, hey, you know, this was the question, this was the answer. Was this deceptive? Was this, you know, related to like manipulation, betrayal, physical harm, all that stuff? And then the model just outputs the answer. And so that's how they do it in this case. And I think that's just generally how you can do it in any case, which is that the kind of in context learning ability of these models mean that you can take a general model and prompt it and be like, hey, I'm going to show you, you know, an example of somebody trying to, let's say, like, have a conversation, and you need to tell me whether, you know, that response is blah, deceptive, you know, positive, whatever your task is, and then, you know, have that as your prompt. There's a lot of tricks to prompt engineering, but of course you could like make your model even more specific by adding examples, saying like, you know, if the person said, for example, oh, I swear I'm not lying to you, like that might be a little sketchy. If the person said, you know, oh, I want to like build a bomb, that is like violence related, whatever, like these examples. And then with that ability of these large models to learn in context, you can take a general model and have it do your specific task very well.
That's awesome. Marwa, I hope that gave you a little bit of clarity. Let's see, any other questions coming in? There's one question from Manpreet. He asked, I mean, this is like a philosophical question, or at least it starts with it. How can we trust humans for specialized domains or languages that need expertise to even understand the context? How would even QA work?
Yeah, so I think like that's funny. It's kind of like a the chicken or the egg question. So like I think you can trust humans. Well, can you trust humans is a broader question, but I'll answer the like maybe more localized version, which is for many tasks where there's specific knowledge that's required. Let's say like, I don't know, like a medical task or coding. You know, the answer isn't going to surprise you that like a lot of labeling services let you select for people that have that expertise, right? So you might say, well, I want to like grade these like like these samples that are like medical advice. I need doctors to look over them, or lawyers or engineers or whatever. And so in that sense, you can trust humans. Although I will say that if you haven't spent much time labeling data yourself, like I'd consider myself, an expert in, let's say, like engineering or ML. I've labeled, examples just for my own edification of kind of like LM outputs, and it's extremely hard because it's like you have to like context switch, and like read some random like request and then some completion and try to think carefully through bugs. Even if you're good at it, you'll, at least I feel I'm pretty good at the domain, and I'll make mistakes just because you, especially if you're trying to label many examples and you're giving yourself, let's say, like a minute or 2 minutes per example. It's very hard, especially if the task is complex. And so I think that's actually where that's my theory for why these models are sort of like outperforming humans in some cases, is that they're slightly worse than the human experts at it, but they're so much more robust. They don't get tired. They can get through as many examples as you want. And so I think that that's likely what is happening currently, is that just a human rater, even an expert, is going to have a hard time rating many examples. It takes a lot of mental toil, and it's actually quite challenging, whereas a model just cranks away.
Yeah, I think that makes a lot of sense. Well, cool. I think those were the questions I'm seeing so far. Definitely make sure to, what's the best way for people to kind of ask you questions or check in on your material in the future? I think you had something on the last.
Yeah. Yeah. Twitter, if you like it, I'm powered. LinkedIn is here, and I should put it on the slides, but my name's Emmanuel, so I'm Emmanuel@anthropic.com if you have any questions as well that you'd like to send by email. So any of those is completely fine.
Awesome. Thank you so much, Manuel. This was awesome. Have a great rest of the day.
Yeah, thanks so much.
Of course.